All right, in this video we're going to go over the first few questions from the Chapter 2 practice test. So number 1 asks us to identify which intervals are the solution to this inequality. And there's really two approaches we can take when solving a nonlinear inequality. The one that I sort of recommend is to just think about graphing this thing. Just think about graphing it, and then you're thinking about, okay, when I graph it, where are the outputs, the y values, making this inequality true? So in this case, less than or equal to 0. In this case, we do already have 0 on one side of the inequality, and this simplified to one rational expression. If you don't have that, if you have like two different fractions over here, or you have some other number over here, you do want to rearrange it so that 0 is on one side of the inequality and that you just have one fraction to deal with here. Because if I just have the one fraction, then I can follow my rules for graphing rational expressions pretty in a straightforward way. And it's much easier to just say, when are my y values less than 0, rather than, when are they less than 7? The x-axis and x-intercepts and such are important things. 7, not as much. Okay, so let's go ahead and think about graphing this. First thing I would think about when graphing is that my domain is everything except for -2. So -2 becomes an important point because that's a spot where my function is undefined, and that means that my function could potentially change from being negative to positive or positive to negative at that undefined value. The other places where we could change would be at the x-intercepts, and so to find those I need to factor the numerator. So it's going to be x plus 4, x minus 1. And so I have two x-intercepts, -4 and +1, and so those are also places that my graph could switch sides of the x-axis. Let's start putting this stuff on the graph. So I've got -4, x-intercept, +1, x-intercept, and -2, we have a vertical asymptote. Now, because I'm going to think about this in terms of graphing, I also want to know what my y-intercept is. So I'm going to plug 0 in for x. And if I do that, a little bit easier to see in the non-factor version, I'm going to get -4 over +2, which is a y-intercept of -2. Roughly there. And now I need to think about my end behavior. And the easiest way to think about end behavior is to think about actually doing the division. So if I were to do that, x plus 2 on the outside, x squared plus 3x minus 4, go through my division, and I think, all right, what do I have to multiply this x by to turn it into an x squared? Well, that's just another x. Then I distribute that. I get x squared plus 2x, and then I subtract. First terms cancel out, and this becomes x, and there's nothing to combine my 4 with, so it's just 4. Now I do it again. What do I have to multiply this first term by to turn it into this first term? Well, in this case, that's 1. And then that turns into x plus 2. We subtract, and I get a -6. Now, if I ask the question again, what do I have to multiply this by to turn it into this? Well, multiplication in the traditional sense doesn't work because this has a smaller power than that. I need less. I would have to actually divide out an x here. So this is my remainder. And it's so important to emphasize that this expression in the numerator now, x plus 1 plus negative 6 over x plus 2, that's the same thing. This whole thing together is the same as this. And so for large values of x, I'm going to have negative 6 divided by a really big number, which is essentially 0. So this remainder goes away, and the end behavior of my graph is just the x plus 1. I'll draw a very rough sketch of the x plus 1. Something like that. And already I can kind of see the shape that my rational graph is taking here. I've got to follow those those asymptotes and go through my 3 intercepts. And that should look something like this. And I can see just by looking at my graph for what values of x are my outputs less than or equal to 0, less than or equal to the x-axis. And so I can see in the graph it's anything over here, we're below the x-axis, and then anything from here to here. So that's going to be negative infinity to negative 4, including the negative 4, and then negative 2 to positive 1, including the positive 1 because it's less than or equal to 0, and it is equal to 0 there, but not including the negative 2 because the graph isn't equal to anything at negative 2. So my answer would be this one. All right. In this case, they've given us not a rational function, but a polynomial function this time. And they've told us that 3i is one of the zeros, and then we're supposed to find all of the factors, or at least identify which of these are factors. And one thing I know right away is that if 3i is a 0, one way to write that is that x equals 3i. Another way to write that, of course, is that x minus 3i equals 0. So I've turned that x-intercept, that 0, into a factor. Now I also know that the only way I could possibly get this I when solving this equation is if I took a square root. Right? The I is the square root of negative 1, so that's the only place that can come from. And when I take a square root, there should be a plus and minus. So I have another factor right away of x plus 3i. And so the general idea is that if these are both factors, then I should be able to divide them evenly into this function here, and then see what's left over. But before I divide, I would like to get these two to be simpler, and I would actually multiply these together to get rid of the i's. So let's go ahead and do that here. So we're going to have x plus 3i times x plus, times x minus 3i. And so that's x squared minus 3ix plus 3ix minus 9i squared. The middle two terms, of course, cancel out, and then the I squared, since I is the square root of negative 1, square it, you just get negative 1. And so you have negative 9 times negative 1, which is going to give me x squared plus 9 squared. So that's one of my factors. And now I need to divide that, so I know this is a factor, into this and see what's left over. A lot of division in this problem, I guess, huh? Or in these two. So I've got x squared plus 9, 3x to the 4th minus 4x cubed plus 12x squared minus 36x minus 135. Same process as we were outlining before. What do I have to multiply this by to turn it into this? And that's going to be a 3x squared. Distribute it back out. 3x to the fourth plus 27x squared. Subtract. Now I left that big old gap just to help me line up like terms. There's nothing to combine my 4x cubed with, so it just stays. Now I'm subtracting the negative 20 or the 27, so that would leave me then with a negative 15x squared. There's no other like term, so it's just negative 36x minus 135. And then we do it again. What do I have to multiply x squared by to turn it into 4x cubed, or negative 4x cubed? Well, it needs a negative 4. Negative 4x, excuse me. Negative 4x. Multiply that by the 9. That should be negative 36x. Ooh, I like that already. Subtract. Both of those things are canceling out. Negative 15x squared minus 135. No like terms to combine those with. And I need to multiply this by negative 15. Distribute. Negative 15x squared minus 135. Okay, good news, no remainder. I knew that was supposed to happen, but it's always good when it does. We know that was supposed to happen because we said that x equals 3i is one of the zeros. So we knew that x squared plus 9 was one of the factors, and if it's a factor, that means it divides unevenly. We're not done, though. We need to go ahead and think about, does this quotient, can that be factored further? And so we just take a second and do that. I could do several different things. I could do the big X method, magic box, whatever you prefer. I'm going to just go with some simple guess and check. I think that's what makes the most sense to me. I'm looking for two things that multiply together to give me what I have up here. The only two things that multiply together to give me a 3x squared are a 3x and an x. Now you could say, what about a 3x squared and a 1? Yeah, but that's not helpful. Now I'm thinking about what two numbers multiply together to give me negative 15. Well, there's more choices this time, but not that many. Excuse me. Feels like we're going to need like a 5 and a 3 here. Could be a 15 and a 1, but I'm going to go with a 5 and a 3. And I'm thinking, okay, if I put the negative 5, if I do it this way, well, now I've got 3 times negative 15, which is negative 45 plus 3. Well, I need to get 4 in the middle, so that's, sorry. I wrote that wrong. Let's fix that. I was thinking too far ahead of myself. That should have been a 5. So I'm multiplying here 3 times negative 5, which is negative 15, and then just adding 3x to that. So that's not going to get me all the way down to the negative 4. But if I switch those two, make this minus 3 and this plus 5, now 3 times negative 3 is negative 9, plus 5 is negative 4. That's what I want. So both of those, 3x plus 5 and x minus 3, are other factors. All right, so that's the first two problems.